Quadratic inequations are solved using the quadratic equation solutions. However, the answer is given as a range of values rather than 2 points. For example, when solving the quadratic inequation x squared minus 2x minus 3 less than 0, we solve the quadratic equation minus 1 and 3. We now consider the graph of the quadratic. We want to find the values of x that make this less than 0. That is, we want the points below the x-axis because they have a negative y-coordinate. The solution is the range of values of x between minus 1 and 3, not including them. If the question had a less or equal sign, then yes, we should include those 2 points. As another example, let's solve the inequation x squared minus 3x minus 10 more than 0. We factorize the quadratic and we use these two solutions, minus 2 and 5. Now, pay attention to the graph. We want to find the values of x that make this positive. That means above the x-axis. The solution has two parts. The left-hand part for values of x below minus 2 and the right-hand part for values of x above 5. Notation is important, so take care of it. This is the way you are expected to write it. Let's see a couple more where the quadratic is negative. We have an already factorized quadratic, so it is easier to see why it crosses the x-axis at 2 and 5. Now, pay attention. We want the part of the quadratic above the x-axis. Yes, we want the points with y-coordinate positive. That means any values of x between 2 and 5. Let's try that once more. We need solving the already factorized quadratic. It crosses the x-axis at minus 3 and 1. At those places the y value is 0, and we also want the places where it is below 0. This includes any values of x below or equal than minus 3 and any values of x above or equal than 1, because the parabola falls below the x-axis for values away. So basically, the tricky bit is to analyze the graph and decide on the range. So, with that in mind, I'm going to provide the graph and it is your turn. Stop the video here and solve each quadratic inequation. Right, the first one has solution any value of x between negative 8 and 2, not including these points. The second one has solutions x less or equal than minus 3 and x more or equal than 6. The third one has solution any x between 1 and 10. The height of a right angle triangle is 2 centimeters less than its base. If the area is less than 7.5 square centimeters, what is the length of the base? We can write an inequation about the area. A half of the base x times the height x minus 2 must be less than 7.5. All we have to do is rearrange the terms in descending order. Stop the video here and try. Right, multiplying both sides by 2 and moving the constant 15 to the left, we end up with x squared minus 2x minus 15. We factorize and solve for x. Any values of x between negative 3 and 5. Any? Well, not really, because if you think about, before accepting any algebraic solutions, we need to consider how they relate to the context of our problem. The shortest length is x minus 2, so x must be greater than 2. Otherwise, we would end up with a negative length, which makes no sense. So the only valid solutions for x are any values greater than 2 centimeters, so each length is positive, and smaller than 5 centimeters, so the area of the triangle is less than 7.5 square centimeters. Want more practice? Access full courses, quizzes, and worksheets in the link below. Happy learning!